Please welcome Noah. Thank you. It's great to have LEAG back in DC. And as Bill Farrell proved, it's not a LEAG meeting until someone falls off the stage. And I just hope that's not me. All right. I want to thank all of the other folks who work with me at Goddard to keep LRO going. John Keller, who's watching online, undoubtedly correcting everything I say. Barb Cohen, who's in the room if she's back from lunch. Her name will come up later on, someone everybody needs to know. And of course, Tim, Maria Banks, and Andrea Jones, who keep the ship afloat. What's up with LRO? Well, this has been an incredible year for all of us lunatics, but especially for LRO. We've celebrated now 10 years in lunar orbit, which is, again, about 8 years longer than anyone thought LRO would go. So, you know, when I see all these Mars rovers, oh, we've done all this stuff at Mars, I think, well, we've been orbiting the moon now continuously for 10 years longer than any mission has ever done. We have a happy home sharing management responsibilities between the LDEP program and SMD. That's worked very well. It's great to have advocates in as many offices at headquarters as possible. This year was going to be much more exciting for landings on the moon. We supported Beresheet and Vikram landing site characterization, and of course have supported the accident investigation for Beresheet and are continuing to search for Vikram when the opportunities arise. On September 15th, we started our 4th extended science mission. It's a 3-year extension this time, which will take us out to September 2022. I'll talk a little bit more during the course of my presentation about ESM-4, what we're proposing to do, and some of the ongoing activities for our mission, as well as maybe a little bit of advice. I know there's a lot of prospective PIs for lunar missions out there, and I can think that I might afford some opportunity to discuss some of the things that we've learned about keeping LRO afloat for 10 years that may be useful. We had a few weeks ago a successful International Observe the Moon Night. This was a global celebration of the moon that we initiated 10 years ago. And just so everyone can get it on their calendar, September 26th will be next year's International Observe the Moon Night. There's a few other events that come up that we have nothing to control, and these are lunar eclipses. And lunar eclipses are very exciting opportunities for LRO to test our batteries. Let's put it in that positive spin on that. On May 26, 2021, we'll have a 15-minute total lunar eclipse. It's not as extended as the 2 subsequent ones in May, almost a year later. We have an hour and 25-minute eclipse, and then in November of 2022 into ESM-5, which I shudder to think about at this point, but we'll get there. We have an hour and 25-minute eclipses. These become very important opportunities for us to test the durability of our spacecraft. We've managed to survive through multiple eclipses before. I have no doubt that we'll do the same in these upcoming total lunar eclipses. There are some penumbral and partial eclipses between now and then, but the total eclipses are the real testing opportunity for us to basically be in darkness for an extended period of time. Something that I'm all too familiar with 3 little children. The senior review. This is something that now is done every 3 years for NASA's planetary missions. The 3-year cadence has been proven to be much more manageable for us. 2-year cadence pretty much meant that we had about 6 months of starting up the next extended mission before planning for the next proposal opportunity. I include some of the requirements that go into the call for the senior review. Why do I do this? Well, again, we have a lot of prospective mission PIs. I want you to start thinking about your extended missions. This should be shared pain. But you know, not only as what one would expect, you know, how do we relate to the decadal survey and groundbreaking science? How do we support LDEP? But you know, are we doing unique science? Of course, the answer is yes. Are we archiving our data in the PDS? That's why Maria Banks has become the most important person on LRO. Bringing on new investigators where possible, and bringing on new PIs and participating or project scientists. And so this has become very important. This is not an easy thing to do for a mission that's in operations. This requires work, paperwork, and approvals at headquarters, but it becomes scientifically incredibly valuable to bring on these new perspectives through new co-Is. And then, of course, showing that the science community actually uses the data. This is something that's very important. If we're putting data into the PDS and it just sits there unused, and no one's doing analysis on it, no one's proposing to the NASA RNA programs to analyze the data, that's not useful at all. And just as a bit of, again, proof that this is an intense process, we submitted the proposal a week before LPSC, and we started really getting down and dirty, writing the proposal and coming up with ideas in September of 2017. This is not something we take lightly. We, of course, have a traceability matrix brought to you by my optometrist's office. It's not a NASA proposal unless it has an STM, right? But we focus on three main areas, of course, the three prominent processes that we study and have been studying for now a decade: volatiles, volcanism, tectonism in the interior, and regolith and impacts. And I just highlight some of the types of investigations that we included in our ESM4 proposal. Many of these investigations, in fact, most of them require multiple data sets. We really are going towards a new model for operating LRO and operating the science teams of integrating the teams together between joint science teams, all hands science team meetings where we get as many different people together to talk about the LRO science and the science that we want to do going forward. We just received a few weeks ago our subcommittee report. We had kudos across the board about the contribution of all of the instruments to the new observations, new modes of observation, and using our spacecraft in an innovative way. We haven't received the final word from headquarters saying, yay, verily, go forward and do what you propose to do. So until then, nothing is written in stone. But I don't anticipate any great shift in what we plan to do. In fact, I'm really expecting positive things from headquarters. You see below the subcommittee report, the scores that we told, we got for our science proposal. 4 excellence and 1 very good. That very good will haunt me for the rest of my life. Oh, no grudges though. It's okay. It's okay. So yesterday, Jen Hellman talked a bit about the future of LRO. So I want to emphasize that the future for LRO is positive. We took a very proactive stand now 2011 to go into what we call a quasi-stable orbit. This takes us high above the North Pole and low over the South Pole, and we've maintained that orbit now ever since. We've done some phasing maneuvers, some burns to adjust the orbit over time, but now we're really letting Newton drive the spacecraft, and you can see for the past several years we have done none of these major burns to shift our orbit. In doing so, we reduce the amount of fuel. We have about 18.3 usable fuel remaining in the spacecraft. We have accounted for line loss in that calculation. Just to dump momentum out of spacecraft, to do eclipse phasing maneuvers, to phase for potential science observations, we use just over 2 kilograms of fuel per year. Simple math dictates how much fuel we have left to do those simple momentum unloads. It takes us out to about 2027 or thereabouts. You know, LRO is a complicated spacecraft. It's an amazing spacecraft. We monitor many subsystems: the battery, the gimbal that points our solar array, our miniature inertial measurement unit, which we use to precisely know our orientation of spacecraft. We actually turned that off last year to maintain its life to use only in emergencies. And so we've developed an entirely new method of operating the spacecraft over the past year to allow us to maintain that system for future emergency use. But at this point, we know the systems are degrading, yet we don't deem any of them to be mission threatening beyond this fuel use limit for the spacecraft. And so if we project forward, let's look at what LRO will do. So first, the famous Ring of Fire map. We're looking right above the South Pole. Here's Shackleton. And so what this is basically a heat map of our number of seconds over a particular location during ESM4. And so what this is showing us is that there are areas that we'll pass over a number of times. You can imagine if you go back to when LRO was first in orbit, we were passing directly over the South Pole on every single orbit. And so as this orbit has evolved, as we move away from the South Pole, we actually get a density of coverage that now extends out to about 85.5 degrees. This plot at the bottom here shows the evolution of that inclination with time. And so as we go out to the early 2020s, that Ring of Fire will extend out to about 84.5 degrees. Again, building up coverage data for those areas. I just include at the right a barely legible view of the map, but showing that we are now covering, again, some of these key locations that may be future destinations for Artemis. Our orbit continues to evolve, and so this is, again, periapsis and apoapsis. Eventually, we'll get to a point where we are at almost 100 kilometer, just under 100 kilometer circular orbit, and then eventually it evolves away. This slow breathing of our orbit just happens naturally, and it really affords us, again, an opportunity to maintain fuel, Just, again, let the spacecraft fly where it may. At this point, our flight dynamics lead has projected out several years beyond what we see here, and at no point does the altitude get to 0, which is a relief for LRO. Probably not a relief for the missions that want to land, but that's their problem. So I show a plot here of the coverage of LROC NAC images over the South Pole. You may be looking at that and saying, I don't see anything, and that's the point. At this scale anyway, we've covered, at least with some form of NAC image, most of the South Pole. If you get very close, there's a few areas where there are actually little gray areas. Moon actually peeks through the map. This is a reminder, though, for those that are planning missions to the moon, don't take for granted that, oh yeah, well, they must have what we need to plan our mission. Well, we may not. And so that's why I add Barbara Cohen's name up here again. She is our Associate Project Scientist for Commercial Lunar Landing Site Support, as well as any mission, other landed missions. And so Barbara really is the point of contact that we should be maximizing her time with, because I know as her lab chief that her time is very limited. But it provides an easy access point to getting at the data that you may need to ensure that your mission is a success. I'm going to show now a video. You get to see how rapidly I click, working through our amazing quick map tool that's hosted by the LROC site at Arizona State. And if this goes too fast for you, I can give you the video. I can sit down and share a little bit of how to track down the data that you might want to find. This goes through looking over the South Pole. Again, overlays of incredible slices of our data, of not just the NAC or WAC data, but other instruments, including M-Cubed, Carly, basically allowing you to see what we have and then actually get at and download and begin working with the data. And so again, this is that same map that I showed, but as you zoom in, eventually you start seeing the individual footprints of NAC frames that have been collected over a decade now. Again, remarkable. And as we get closer and closer, you can start seeing all of the different rectangles. If you drop a point anywhere on the surface of the moon, as I will do in a moment here, you'll actually be able to see what NAC images are available at that point for you to download and begin scientifying on. So there's a great tool called the Projected NAC, which actually doesn't show you everything, but it shows you a selected set of images at that one location, which you can then interrogate further and actually get a sense of really what data we have at different illumination conditions, different geometries, and so forth. So you can see, for instance, the very bottom one, that was an image that was collected when that particular spot was just in shadow. You can also, again, access other data sets through this tool, which is a really wonderful way to, again, interrogate all of the data that's been collected from LROC, as well as many other data sets as well, and some of the derived products too. So this is something that I am so proud to share with the community, and not that I share with the community, Arizona State shares it with the community, but it's an incredible resource. If you go back to the first LEAG that Sam talked about, to think that we'd be at this point now is not just we have pictures of the South Pole, but we've got 20 pictures of a particular location of South Pole. We've got data that will enable all of this future exploration of the moon for years and years and decades to come. And eventually the video will end. But of course, there's more to explore with this great tool that's out there for use. So for instance, in this one particular frame, there's a link that you can go to actually begin downloading and working with that particular frame. It's quite remarkable. And again, to emphasize, because Carly's here, you can drop a point and get M-Cubed spectra for that one location. M-Cubed is an incredibly valuable data set that has to be used more as well. Let's talk about the PDS. We have been releasing data now every 3 months for the better part of a decade. We now actually deliver LROC data monthly, which is quite remarkable. And so this is something you can set your calendar to every 3 months. If it's a month divisible by 3, there'll be a new batch of LRO data delivered to the interwebs. Some recent highlights: Lola has updated some of their global maps, both topographic and roughness maps for the whole moon as well for the poles. And then a whole bevy of amazing data sets coming out of the LROC team. MinRF has been delivering their bistatic observations to the PDS. I'd like to propose that we rename the PDS the lunar and planetary data system because we now comprise 65% of the data that's in the PDS. Just a suggestion. But let's not make that a finding. Or maybe we should, I don't know how that works. There are many ways to access our data, short of talking to any one of the many folks on LRO who are here, a number of websites. And actually I highlight this downloads page on the LROC website, which has some of the sort of the larger global products or larger products to download. It's a really great and valuable resource. Lola's product data is served out of MIT, and then the PDS archive has pointers to get to the other data sets as well. Just wanted to highlight the importance of communication and outreach. We did the International Observe the Moon Night in late August, early September, late September, excuse me. And this was a video that was put together featuring the event at NASA Goddard. We had Charlie Bolden come talk to us and actually spent the entire night working the crowds. He was there supporting a military family support organization that he's involved with now. It was wonderful to see him so excited about the moon. But it was really great. Lots of kids, families there, and I think the enthusiasm for the moon that we've seen this year has really borne out from a lot of our hard work to communicate the excitement, the importance of the moon, not just for science, but for inspiring present and future generations to get into sciences, to get into engineering, and really care passionately about looking not just down at your phones, but looking up to the sky. And so as I prepare for the future, this is a map we've put together of illumination conditions in 2024. I was talking to Brad Jolliffe on the way back from lunch today, and he said, boy, how far have we come? Not only do we have now amazing topography and color information for the moon to generate this view of what the future is going to be like, but we can enable this future thanks to the data that we've collected from LRO. This comes out of our scientific visualization studio, and it's my goal that with LRO in orbit at 2024, we'll be there at the same time humans are at the moon. And with that, I look to a little closer portion of the future. Sam talked about riding an elevator with someone at JSC earlier, at KSC this morning. You can imagine the guy sitting next to me at the baseball game a few weeks ago. And why are you looking at the scoreboard all the time? I said, this is a little bit more interesting than what's going on in the field right now. Right now. It was between innings. It was fine. It was okay. It was okay. With that, I'll close. And I know I've taken too much time, but take a few questions. Thank you.
Okay. It's John Gruner, JSC. A lot of people in HEO-MD are using this tool now. We've trained a lot of the people in the EVA world and mobility world how to do these things with topographic slopes and whatnot. But one of the challenges that we all have is the colored maps that you're talking about, particularly the temperatures at the pole. Mm-hmm. When you move the cursor around, you get latitude and longitude changing, but you don't get a numerical value. You still have to look at the color on the map and the color on the key and make a subjective guess. Maybe Barbara's going to tell me that there's a better way to do it, but hopefully that's something y'all can add.
I'll defer to Barb. Go, Barb.
If that's a capability you would like, you should make sure to let the people who have funds to make that happen know. We've submitted a proposal to add that capability and several other capabilities that the human exploration people have asked for. It's an unsolicited proposal, but there's not currently any funding. So make your
interrupt. It's almost done. Very, very soon.
But ingesting it into QuickMap too, it takes time and effort.
Yeah, we're working. Yeah, we've been working on that for a long time, eking out the funds. Right. Yeah, it's almost there.
Wonderful. Okay.
Thank you, Noah.